Okay, in this video, I want to go through the thought process of solving a one-sample hypothesis test. We have the following problem. Many grocery stores and large retailers such as Walmart and Kmart have installed self-checkout systems so shoppers can scan their own items and cash out themselves. How do customers like this service and how often do they use it is the question. Listed below is the number of customers using this service for a sample of 15 days at the Walmart on Highway 544 in Surfside, South Carolina. Here is the question at hand. Is it reasonable to conclude that the mean number of customers using the self-checkout system is more than 100 per day? Use a 5% significant level. So in this problem, when I look at it, I know that I'm going to compare a survey result to a value. That value is 100. And the sample that we actually have the raw data to calculate our sample statistics. So let's go ahead and open up the starting file for this problem. Okay, we see the starting file here. We have the question at hand. Let's go through the problem and document what we know at this point. In terms of the value that we're going to compare our survey results to, the value is going to be 100. Not to be confused with the label here, values, which represents the survey values of how many customers were using these self-checkout lines. So maybe here, let's call this sample values, so we're not confused. Let's go ahead and utilize this formatting scheme throughout the problem. Now we got to list the information about the survey itself. Let's see what the count is. We can count the number of sample results from the sample itself. We get 15. We are also told that in the problem. Let's see, what else do we know? We know that the alpha value is going to be 5%, 0.05. Let's see, now everything left in the problem has to be derived from this sample results. So let's calculate the sample mean. It's going to be just an average of these sample values. The sample standard deviation is calculated with a STDEV dot, and we have to make a decision here. Is this a population or is this a sample? Well, we were told it was a sample, so let's go ahead and use .s and calculate the standard deviation based on the values there. Okay, so after we apply some formatting to these cells, let's start talking about the problem. I'm just going to format these with 1 decimal place. That should be sufficient. Okay, so let's start talking about the problem. Question got cut off there. Is it reasonable to conclude that the mean number of customers using the self-checkout is more? So that's the keyword we want to document. So what does this keyword of more imply? It implies that we are going to test the right tail test. The right tail test is needed. So let's go ahead and format this. We need to know the characteristics about a right-hand test, so I'd recommend going to the formula sheet. We start here. We can verify that our interpretation of the keyword is okay. We have a keyword of more, which is very similar to greater than, so we definitely are using a right-tailed test. Why don't we go ahead and copy these images over to our spreadsheet just so we can look at this later when we're solving the problem. So let's click on that, copy this, and paste it into our sheet here. And we can make this a little bit bigger. So the only area of the distribution we're concerned with is this right tail. We need the critical value and we need the test statistic, and we're going to make our determination if we can reject the null based on where the critical and test statistics lie. So let's go ahead and write out the null hypothesis. H0 is going to be the statement our mu, our sample mean, is less than or equal to the value. Okay, so that value again is that 100. A sample mean is actually 109. So stop and think about what this is really saying. This test is actually saying, let's test that 109 is less than or equal to 100. That's what we would conclude if we do not reject the null hypothesis. Of course, we want to be able to reject the null hypothesis, and we want enough evidence that we can accept the alternative. So what does that imply? Well, this is more logical. The sample mean is greater than the value. And again, we're testing the number of customers. So that's good. That means the more actually is better. If we're dealing with time, then we'd have to actually think about that. Okay, so let's use some formatting here. This is our null and alternative. Therefore, we need their critical regions, and we need to know if we're dealing with a t-test or z-test. Okay, so nothing in the problem to me has indicated that we know or have been explicitly told information about the population standard deviation. So we just have a small sample here, so we're going to utilize the t because no information was given about population standard deviation. Okay, let me go ahead and merge and center. Okay, so now we've decided on a t based on the limited sample size and not being provided that the population standard deviation is of a certain value. So let's go back to our formula sheet. We are using a t, and we are testing the right hand side. This is the test, and I just go through this as a stepwise approach. All the t's are calculated the same, the z's are calculated the same. It just depends. The only difference is an S, which is shorthand for the sample standard deviation, versus sigma, which is population standard deviation. Everything else is the same. Let's calculate our test statistic. So our test stat, t stat if you will, we'll also need a test critical. Our t stat is going to be equal to the sample mean, 109, minus 100, divided by standard error. Standard error is sample standard deviation divided by square root n is 15, parenthesis, parenthesis. So we have 3.65, and that's definitely on the right hand side, so that's a good indication we're doing this right. Test critical, at that point we need to look up the formula. Let's go down to the next page. We're dealing with the t-test, we're dealing with the right test, and we can validate that we've written our null and alternative hypothesis correctly. It doesn't have a lower bound, but it does have an upper bound. Let's copy that formula. All this formula requires is 1 minus alpha and degrees of freedom, which is degrees of freedom is not something we calculated, but we can embed that in the formula. So let's double click that cell, paste. We know alpha. Alpha is 5%. Degree of freedom, it is always n minus 1 unless specifically stated elsewhere. for a single sample test, it'll always be n-1. Later we'll get into some problem-solving techniques where it is calculated for us. Okay, so let's go ahead and use some Format Painter through the analysis, and let's go ahead and bring up Paint, not that option, but this option, and draw our situation here. We have a normal distribution, looks something like this. Of course, those tails go out to infinity. We have a center. We are definitely testing the right tail, so we have this to consider, which means our rejection region is defined by the test critical. I'm just going to label this as T critical. We have to determine where our test stat is. Our test critical was 1.8. Our test statistic is 3.7. That means it's to the right. So TS is over here. This is the rejection region. So our test statistic is in the rejection region. So we're going to make a conclusion that we should reject the premise that our sample mean is less than or equal to the value. In other words, we can conclude, oops, misspelled that. We can conclude that the sample mean is greater than the value. So let's go ahead and write that in that manner. Sample mean is greater than the value. Okay, so more explicitly clear, let's go back to the question. Is it reasonable to conclude that the mean number of customers using the self-checkout is more than 100? Yes. The sample, yes, well, we could just say yes, it is reasonable. Users of self-checkout is greater than 100 a day. So let me I'll just make this merge and center and wrap the text so we can see that clearly. So there you go, that's the solution to our problem. We've determined that yes, in fact, we have more than 100 customers a day using the self-checkout. So it could be that this problem is embedded to a break-even point that says, well, we can actually support the cost of buying these self-checkouts or something related to that analysis to say, yeah, maybe 100 is the break-even point. Can I statistically say it's greater than 100 to justify the cost of this new machinery?